Hello guys, welcome again to another video session by Mr. Moya, and today we now beginning to look at some exam papers. I think it's pretty crucial that whenever you feel you've learned something, you check yourself against the exam paper. I think that approach has been overstated in so many sectors of education that it's incomplete to say you've understood a concept without checking yourself against the examining board that you're going to be writing at the end of either that year or that term, or at the end of a particular level of learning. Okay, so we're going to be focusing a lot more on exam papers, and we're going to try and keep the videos short because I noticed that the more time I spend, the more bulky they get, and it's difficult for you guys to actually work with that. So we're going to try and keep them short. So I'll, for example, do question number 1, all of it, finish it, and stop, and then move on to question number 2 in a different video. Okay, so as you can see there, we got question number 1, which has to do with solving for x. I think that's been the norm. And as per the usual, looking at this is like you're looking at two numbers. Okay, so we're going to call this one bracket A. We're going to call this one bracket B. And because it's brackets, they're multiplying each other to give you 0. I remember having this conversation with 2 students yesterday. And we were talking about what is the condition for you to get a 0 when you multiply. So we know for a fact that if I say, for example, 0 times 10 is equals to 0, and 10 times 0 is still equals to 0, or 0 times 0 is still equals to 0. So that's where it all comes from. So 0 times 10 is equals to 0. So 10 times 0 is equals to 0. So 0 times 0 is equals to 0. So the condition for me to get a 0 from multiplying two numbers is that one or both are 0. That's the precondition for this. And if you notice, that's the reason why we end up saying, oh, how do we solve this? We end up coming and saying, so it means that either this bracket is equals to 0 or this bracket is equals to 0. Okay, so I'm just going to undo this so we can create some space, and we then continue with that there. So that's going to give us either 3x minus 1 is equals to 0. I prefer to write it going to the right, or x plus 4 equals to 0, for reason that I want to use the space below that. So in this case, I'm going to indicate what I'm doing. So that gives me 3x is equals to 1, because I know that if I take my number over the equal sign, the sign changes. So if it's a negative, it changes to a positive. And if it's a positive, it changes to a negative. You have to watch one of our other videos again on this about why the sign change happens that way. Some of these things you need to understand where they come from so that you do not struggle much with them. Okay, and then the next thing, because my 3 is multiplying, to remove it, I'll need to divide both sides by it. Okay, we're going to talk again, that's the other video that we're talking about. So that gives you x is equals to a third. Or here, taking that side, because it's positive, it's going to become a negative. So those are the final answers that we have on there. Okay, so that's the final answer of that one. Going on to number 2. So 2x squared plus 9x minus 14, corrected 2 decimal places. Already, just by reading into the question, the fact that they're talking about 2 decimal places means that your answer is going to be either in surd form, or it's going to have a couple of decimal places, usually infinite, without any repetitions, okay, or pattern to them. So already you can tell from here that you're going to have to use the quadratic formula. How does this help you? You will not bother trying to find two numbers that if you multiply you'll get the 28, the minus 28, and if you add them you get the 9. Okay, because normally when they ask for 2 decimal places, you already know that it's numbers that you cannot just just get out of your armpit from nowhere. You will have to use the quadratic formula. It's a hint. Okay, and I want you to take note of that when you're dealing with questions like that. Okay, so proceeding on. So I'm just going to go straight to the quadratic formula there. So that's going to give us x equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, it's a great thing because I've seen students that actually, let me just write this here, 2x squared plus 9x minus 14. Now, I was saying students that quote what their a is, what their b is, and what their c is. This is a very crucial step, I think, in as much as it doesn't give you marks, it kind of clears your head without you having to do a lot of mental gymnastics in answering your question, because remember, in the exam, already you have the pressure from expectations and people looking forward to you coming out of the exam. There is a lot going on in your mind, and you want to focus on trying to maximize your marks, and you want to try and minimize mental work. Okay, as soon as you think something, try and put it on paper. As soon as you think something, try and put it down on paper, because the more you keep in your head, the more potential there is for you to make mistakes and errors that will later cost you, especially if you're going to be carrying forward one solution to the next question. It means your error kind of trickles down to later parts, and they may use error carried forward, they may not. We do not want to base our passing on possibilities. We have to be definite about exactly what we're going to get. So you want to try and minimize the stuff that you keep in your head or that you do in your head. So you want to try and have your question worked out as much as possible. Even if it's for 1 marker, I will prefer to work 10 marks worth of working, just so I'm assured of that 1 mark, as long as it doesn't interfere with my time for the exam. If it takes too long, then yes, I'll skip it, move on, and then come back. But I will give whatever it takes to get that 1 mark, as long as I'm assured. Okay, just because it's 1 mark, it doesn't mean I have to skip stages. It doesn't mean I have to do it mentally. It doesn't mean I have to just write the answer down. Yes, there are cases where you have to do that. If they're asking 1 + 1, definitely you're just going to write a 2. There's no need for you to do anything there. But if they're going to ask you a question and you feel the need to work it out, work it out. Okay. Now coming back to a question. So my substitutions, I insist again that they're made in brackets. It may not make a difference right now, but it does help, especially if you got negative numbers. Okay. That's my A. Like that. So mind you, I'm not going to be doing the stages where a calculator is concerned, because those you can punch them in, whether you punch them in correctly or not. There's nothing much that you can do about that stage. I'm just going to show you the working for our questions here. And so that gives us a -9 plus or minus, square it off. Okay, that's going to be 81 minus, that's going to be a plus because we got a -4 and a -14. And that's 28, 56, 112. My assumption is this is going to be 112 all over 4. Okay, and -9 plus or minus. Now 112 plus 81, that's like saying 81 plus 12, that gives us 93. So that's going to be square root of 193, which is pretty close to, I'm sure you'll accept, 14. So it's like 13.8 or 13.9, somewhere there, all over 4. So our solutions, which I'm going to try and use a different color for, are going to be given by -9 plus the square root of 193 over 4, and -9 minus the square root of 193 all over 4. Okay, this is our working, and these are our answers. Then you just punch them in. Okay, get rid of that now, so we can be able to create the space. Right. Okay, so now we're moving on to the next question, which is going to be this one here. Now, if you take a look at this question, already we got square roots. And I usually insist that if you have fractions or some kind of operations which make you uncomfortable, try your level best to use math principles to undo them. Okay, so in this case, I am going to rewrite our question as 3 minus 26x, okay, equals to 3x. Now, to remove this, remember that this is a power of a half. To remove a power of a half, you can see from my other videos on operations in general. To do that, we'll need to square both sides, okay? Like that. And that will then be moved, so it's like this, to cancel each other out. That leaves you with 3 minus 26x. Minus, now it's 3x times 3x. You might as well just think of this as being 3 to the power 2 times x to the power 2. So that will give you equals to 9x squared. Okay, so because our 9x squared is already positive on the right side, we want to try and take everything to the other side. Okay, so that will end up giving us a 9x squared. Let me take it stage by stage. A 0 equals to 9x squared plus 26 because it's gone over the equal sign, minus 3, okay? So I could still write this. I prefer to have my unknowns on the left side, so I can just eventually just give my answer as being x equals to something, okay? So that will end up giving us 9x squared plus 26, x minus 3 equals to 0. And just looking at this, I'm sure you can be able to tell that with the way the question has been asked, you should be able to find two numbers or something. So I'm going to multiply those two, okay? So I'm going to get a negative 27. So I need to look for factors of negative 27. Now, if I add, I will be able to get a 26. I call it the pitchfork. If you notice, we kind of get like a pitchfork there. For those of you who don't remember what the pitchfork looks like, something like this, okay? So I call it the pitchfork approach, but some call it the two numbers approach. So there's so many names to it. So here, because 27 is like 1 and 27, there's like 3 and 9. It's like so few options, which makes it great. The only one I can see that I can be able to manipulate to get a 26 is 1 and 27. But then, as one student pointed out yesterday, because we then look at the sign of the 26 as positive, which means the bigger number should be positive, and therefore this one should be negative. And that's going to give us 9x squared plus 27x minus x minus 3 equals to 0, okay? And then we factorize this in pairs. And that's going to give us 9x, x plus 3. Factorize a negative out, everything becomes positive. Equals to that. So if you notice, the objective is to make sure you have brackets that are exactly the same. So that gives us x plus 3 and 9x minus 1. So we could think of it as being a minus 1 there, equals to 0. So we get that x is equals to minus 3, or 9x minus 1 is equals to 0. Taking this side, 9x is equals to 1. Divide both sides by 9. Therefore, x is equals to 1/9. That's our second answer. Okay? That's the approach to 1.1.3. Okay? So I'm just going to get rid of that working there. Please alert me if there's any mistakes that we could have made in our working, or some assumptions that would have made that potentially could have increased error, or even much better working. There's no problem there. And similarly, already we can tell that this is a quadratic and this is a linear, okay, from our past videos. So what we're going to attempt to do is to see if there's anything that's common there. There's nothing common between x minus 1, x minus 4, and x plus 11. Okay, so what we are going to have to do is to expand the left-hand side and then take everything to the left-hand side and then simplify it and then refactorize it back and then solve for it. So that's exactly what we're going to do there. So we're going to start off by rewriting our question. That helps us to be able to show exactly where we're starting from. And then when you expand this, for those in the know, again from the previous video, you'll know that this is going to give us minus 5x plus 4 greater than x plus 11. Okay, and continuing there, we take this to the other side, taking this again to the other side. So that gives us x squared minus 5x. Now, because it's a plus x, it becomes a minus x plus 4. Because it's a plus 11, it becomes a minus 11. Everything is greater than 0. There's nothing left on the right side. And then proceeding to simplify that, try your level best to show every stage. And it means that when you're practicing now, practice how you would answer the question in the final exam, in the actual exam. Because if you do shortcuts now that you're not going to do then, you're going to be hella confused when you get into the exams. Okay, you want to be focused, you want to get used to your style of answering questions, your approaches, and you want to be comfortable in your own skin when you get into the exam. But if you're going to be cutting corners before you get to the exam, and then you try to straighten everything up a week or two before, I've seen people get anxious. I've seen people get like they seriously just lose it. Even when someone is saying hi, they'll think, oh, you know, someone's just poking at me or something, and yet it's really just something simple. It's all coming from the fact that you have to adjust your technique from all the days that you've been learning. And then now, all of a sudden, you have all this pressure for all the subjects to adjust to try to be suitable for the exam. Just be suitable for the exam from the word jump. From the day you begin learning for that level or for that particular test, make sure you treat it like the exam. Because I say that the exam is in the preparation. If you fail to prepare for your exam, don't expect a miracle. If you do get one, then probably, but I don't think it's deserved. Okay, I believe everything has to be deserved. The way you work your questions out, the way you answer your questions, the amount of work and commitment and discipline that you show in it, it all has to be deserved, okay? You know, luck and all of that, we do not want to base our entire future on luck and all of that. We want to work for every mark that we get, okay? Plus as well, share with me if you disagree. I would love to learn from you as well. So there's going to be minus 6x on there. Then plus 4 minus 11, that's going to be minus 7, greater than 0. And as expected, because we were not really told about 2 decimal places, do not forget that instruction in the previous question. Here, we're not told that, so we're expecting 2 numbers that if you multiply, you get a minus 7. Now, 7 is a prime number, and I'm thinking 1 and 7. But like we say, you look at this sign here to give you an indicator of what your larger number is going to be, and because it's a negative, it means it's going to be negative 1, sorry, a negative 7 and a plus 1. So that's what we essentially get. But because it's an x squared, we can use the 2 brackets method. It's fairly easy. And that's going to be x plus 1, and then x minus 7, okay? And you get the critical points, if you remember those from our previous video, x minus 1, and x equals to 7. Now, the best way to deal with this, you could have a myriad of approaches and methods. I prefer to just deal with it using this here, right? This here is minus 1, this here is 7. And we're looking for places where, because this essentially represents y. It's a function of x. That's why if you notice a lot of cases we write y equals to f of x, that's what it represents. We're looking for where it's greater than 0. So where is it greater than 0? Or where is it above the x-axis? It's anywhere before minus 1 and anywhere above 7, like that. So our solutions are going to be these 2 range values right there, okay? And I think that should be it for the first part. Just to make our videos short, just to keep them simple, I think we'll end here for today. Okay, thank you very much and have a fantastic day.